Okay, very good morning.
Good morning, sir.
With respect to our previous class, we'll continue the same content on the non-conventional energy sources. Okay, so we discussed definition, renewable, non-renewable, classifications, and source of energy, and need for the alternatives. And these are all things we discussed in our last class. Yes, we'll start a next interesting topic. Indian productions on resource of commercial sources. So commercial sources. So far we discussed total overall energy sources. It includes conventional and non-conventional. Uh, but the today topic is based on commercial sources. Commercial sources means which are the energies are easy to available and easy to use. So those energies are called commercial sources. In that commercial sources, the first thing is a coal and lignite. So both are comes in the coal and lignite. The first thing. Second thing, oil and gas, and hydroelectric power, atomic and nuclear power. Uh, so these are the important commercially available sources. Day-to-day life, these energy sources are very helpful for our daily needs. Okay. So in that first one is a coal and lignite. Okay. We already know that how the coal is formed in our school or in our college. We already studied how the coal is formed, how the petroleum products are extracted, everything we discussed. So this is what the one picture which shows how the coal is formed. So these peat and lignite are the different forms of coal. There are different types of coals. Okay, so the coal, since the evident of industrialization, coal has been most common source of energy. Okay, coal is a most common source of energy, and this coal is used for industry purpose, maybe transportation. Earlier in the train, okay, steam engine, they are using the same coal for the to drive the train. Okay, and for every industry for generation of energy, they use coal. So in the last 3 decades, the world switched over from coal to oil as a major source of energy. So earlier we used coal as a measure, but after in last 3 decades we compared to coal, we switched to the petroleum, crude oil. Okay, it's a major source of energy, and it is simpler when compared to the coal. It's a simpler and clear. That's why we switch on to the uh, petroleum oil. But earlier we are using this coal. So modern steam boilers burn coal in any of its forms of primary fuel. Yes, we know that in the steam engines or in the production of energy, electricity. Okay, so in that the to generate the steam or to produce the steam, we are using this coal as a primary fuel. With the help of this coal only, we convert water into the steam, and then that steam is used to transmit power from one form of power to another form. Finally, we convert it into the electricity with the help of it may be the turbines, or maybe with the help of conversion devices. So the coal developed vegetable. So this is what the one picture which shows that how that coal is formed. The coal developed vegetable matters. So this is what the trees, okay, and vegetables, trees and plants and etc. Which grows in the past geological ages. And trees and plants falling into the water and decay and produces peat blocks. Peat blocks means that trees and whatever the plants are, they are buried under the earth crust, and when the time goes on they will start decaying and produces a peat blocks. Okay, they are gigantic geological upwells buried under these blocks under layer of soil, and soil pressure and heat and movement of the earth crust, they distilled off some of the blocks and gaseous matter to form a brown coal. or a lignite. The brown coal is also called as a lignite. And continuous substrates and actively reduces the coal and gaseous content and progressively to form the different types of coal like peat, lignite, and bituminous, anthracite, etc. They forms a different type. Means how they different means the carbon content. So if the carbon content changes, they change the different types of coals. Like this coal is formed in an nearly more than 100, 200, 300, 400 years back. Okay, and continuously these coal are extracted from the earth crust and used for energy conversions or any useful energy to form. And uh, these coal power stations, first commencing of this power station is 500 megawatt. With the help of this coal, they generated a electricity in 1989. Okay, in 1989 they form a first a coal based electricity plant with a capacity of 500 megawatt. Okay, and so in our India also, Madhya Pradesh, okay, Maharashtra, Gujarat, Goa are benefited from these projects. Means they are installed the power generation from this coal. And this coal is at the time abundantly available. But when the time starts move on, the coal is also slowly it is become emptying. Okay, and one fine day after maybe 10 or 20 years, these coal may exhaust. Okay, so that's why we have to switch on to the a one best alternative, which alternative means not coal alternative, whatever the end product we are getting, that is what a useful form of energy, electricity. Okay, so ultimately the aim is to generate the electricity. Okay, so for to get the electricity we have to find so many alternatives. Those alternatives are capable to without exhausting, they have to produce the electricity. That's why we switch on to the non-commercial. So non-commercial means non-conventional energy sources. And come after the coal, again there is a one more important commercially sources are oil and gas. So oil and gas is an another important, and this oil, almost 40% of the energy needs of world are fed by oil. Nearly 40% of the energy, whatever the energy required is 40% is fed by this oil. Oil means crude oil. Okay, the rising price of this oil has brought considerable strain to the economy of the world. Of course, day by day the oil rate is slowly increases. And so in case of developing countries, so that do not possesses oil reservoirs enough for their own consumptions, with the today's consumption and sources amount of 25 uh, 2.50 million tons of oil at the world's surface for about 100 years, less or more than discovered. Means past 100 years we used this much of oil for the generation of energy. So this oil means I told it's a crude oil. The refining petroleum, a crude oil, produces a fuels. Of course, we know that what is refining. Refining means slowly this crude oil is heated and slowly increases the temperature. And a particular temperature, we get a particular byproducts like diesel, petrol, kerosene, coal tar, etc. So these are the byproducts of this crude oil. And India, it's not particularly rich in petroleum reservoirs. The potential of oil bearing areas are also located in Assam, Tripura, Manipura. So they're all in West Bengal also, and in the valley of Ganga, Punjab, Himachal Pradesh. Okay, so these areas also we got the petroleum crude oil. Of course, we export crude oil from the other Arab countries, but apart from that, there is a small amount of energies. This crude oil is also available in our India. Okay, and by this we can extract the different form of fuels like petrol, diesel, kerosene, and those things are we commonly used for transportation purpose. Nowadays they are most commonly used for transportation for commercial and non-commercial vehicles, but earlier it is used for the production of electricity, or maybe only to run the train. And the next one is gas. Gas is an incompletely utilized in the present, and huge quantities are burnt of the petroleum productions process being in the non-availability in the market. So this gas means you can take example of LPG. Whatever the commercial gas cylinders are available, it is for the cooking purpose. The same gas, it is also one of the petroleum product. It's also a petroleum product which is available below the earth crust. Okay, so the first is it is in the solid means it is in the coal. If it is in the semi-liquid means it is a petroleum or crude oil. If it is in the gaseous state means it is a gas. Okay, and after extracting we converted into a lpg gas, and it is most commonly used in India for cooking purpose. And this gaseous fuels can be a mixed composition such as acetylene, ethylene, methylene, etc. And this can be it is also there are some other forms like producer gas, coke oven gas, water gas, blast furnace gas is also another form of gases. And these things are mainly used for uh, to of course for the production of maybe electricity, or commonly in India we are using for cooking purpose. Okay, so these are what examples of commercial sources. And next is one more important is agricultural waste and organic waste. Okay, so it is also commercially sources, but these agricultural waste and organic wastes are mainly used for cooking purpose in the rural areas. Very lessly used in the urban areas, but most commonly used in the rural areas. And after that, the next third is hydroelectric power. So hydroelectric power, it is also called as a water power. We already briefly discussed in the introduction class. Okay, so hydroelectric power means here the whatever the water is having an energy, it is in the form of potential energy, then it is converted into kinetic energy. After kinetic energy, it is converted into electric energy with the help of some devices called turbines. Okay, uh, and all, and through that we converted. So here hydroelectric power means um, best example is dam. Okay, so in the you can commonly seen in the jog. So in the jog there is a waterfalls. Okay, that waterfalls we commonly, okay, it's a very beautiful and it's a amazing thing. Apart from that, lot of energy is wasting, lot of energy is falling from higher higher level to lower level. Okay, so we are just utilizing that waterfall into a driving of turbines. Once the turbines are driving, means it converts the water energy, that is what the kinetic energy, into the electric energies. Okay, so this is what the concept. And nowadays this hydroelectric power plants are most commonly you can see in the Kaiga is one example. In the Dandeli also you can see a lot of the hydroelectric power plants. In the, of course, in the Jog is also we can see a lot of hydroelectric power plants. So they are very commercial sources. Nowadays, these hydroelectric power plants are fulfill our day-to-day life energy consumption. So here, next is atomic or nuclear energy. So, according to the modern theories, the atomic structure and matters consists of minute particles known as atoms. These atoms are represents enormous concentration of binding of energies. We already seen these things in our second PUC and first PUC. We already discussed what is meant by atoms and how they are bonded, and what happens if the atoms are splitted, and what happens when atoms are combined. And will generate, once the atoms are splitted they will generate the energy, or once the atoms are combined they will forms the lot of energies. Okay, and these the controlled fusion or fusion reactions behave unstable amount of energy. It, for example, is uranium 235, thorium 232, the and some of the artificial elements like Pu 239. Okay, so these are the some of the elements, and these elements having an atoms, and these atoms once splits are combined they forms enormous amount of energy or liberate large amount of heat energy. This enormous release of energy from the relative small masses, they are very small masses of molecules, and these source of energies are great importance, and they fulfill major electric requirements in our country. The energy released by complete fusion of 1 kg uranium is equal to the heat energy obtained by burning of 4500 tons of high grade coal. Means 1 kg of uranium 235, whatever the energy is produced, uranium 1 kg, which is equal to whatever the amount of 4500 tons of high grade coal is burned. So it will produce whatever energy, that energy is equal to this uranium energy. You just imagine. Or 2200 tons of oil, crude oil. If you burn 2200 tons of oil, whatever the energy is produced, the same amount of energy is produced by just 1 kg of uranium. And this produced nuclear fusion or fusion reactions. Okay. And of course, we will discuss this nuclear and hydroelectric power plant in the future coming topics. And this is another commercial uh, source of energy. Okay, so these are the some commercial available energies. Okay, they are commercial, and of course they are economical. When come to the non-commercial source of energies, they are a bit costly, but here they are, compared to that, they are little bit economical, but the thing is they are exhaustible. Some of the silent features of or merits of non-conventional energy sources. A non-conventional energy sources. So far we discussed as conventional is also called as a conventional, is also called as a commercial. Non-conventional is also called as a non-commercial sources. Okay, so non-conventional energy sources have some of the advantages. They are available in the nature. The non-conventional energy sources are available in the nature. Example, solar, wind, okay, or hydro. They are freely available on the earth or nature. Of course, they are free of cost, but conversion rate is very high. They causes no or very little bit pollution. Of course, very little bit pollution. But compared to the coal and petroleum products, they produces more pollution. But these solar is produces very less pollution. Wind produces very less pollution. So like this, they are very eco-friendly, environmental friendly sources. And of course, they are inexhaustible. If you use continuously for 100 years, 200 years, but they won't exhaust, they won't empty, even they will regenerate. They are inexhaustible, and they have very low gestation period. So what is meant by gestation period? Means installation period. Means if you just take an example of solar panel, means solar energy, conversion of solar energy. Okay, so gestation period means installation period. So the solar or wind power plants are with a short span of period we can easily install when compared to the nuclear power plant, when compared to the coal power plant, when compared to the hydroelectric power plant. Okay, so for installation of one coal power plant or a nuclear power plant may take 3 to 4 years, but for windmill or for solar energy generation power plant, we can install easily within a year. We can easily install. So gestation period is very less compared to the commercial sources. And of course, these non-conventional resources are having some demerits, like though they are available freely in nature, of course, they are free of cost, but the cost of harnessing energy NCS is highly high. Means the for the devices which convert from one source to another source, they need some devices which having initial cost is very high, and these available dilute form of energies. Means the coal is having a very crude, a raw form is available, but the solar and wind, they are available in the dilute form. So the efficiency is very less when compared to the commercial energy sources. And certainly availability means they are not continuously available. The coal is continuously we can extract from the earth crust from 24 hours, but the solar energy is not available for 24 hours. Only for 8 to 10 hours it is effectively available, but rest of the period it is not available. Wind energy, wind also some in the peak time it is more energy, and in the sometime there is no wind flowing, so less energy. Like this, the availability is very uncertainty. It is depends on the natural phenomena. It's a one drawback. And difficulty to transport this form of energy, means the transportation of this energy from one place to another place is very difficult. So solar energy, we of course it is highly available on the dry land, but transportation of dry land to some of the other places is highly difficult. So these are the some drawbacks of conventional, non-conventional energy sources. And come to the advantages and disadvantages of conventional energy sources. Conventional means commercial. Commercial is nothing but an conventional energy sources. So advantages are, example, coal. Coal is a very cheap, easily available, and also produce a very effective. Efficiency is very high. Second, security. By sorting the certain qualities and energy available can be ensured for the certain period. Of course, there is a lot of grades of coals, and high grade of coal produces in high energy. Low grade produces low energy. We can ensure that energy is ensured. The production of energy is ensured. It is not varying. And conveniency, it is very convenient to use. Coal, just we can use directly coal. By burning up the coal, we will produce energy. But solar, it is not like that. We have to install the panels, and from panel to, again, there are so many devices which convert some solar heat energy to the electric energy. We need so many devices, so many processes. And of course, they are having a lot of disadvantages. The fossil fuels having very highly pollutant. They contain carbon dioxide, carbon monoxide, nitrogen oxide, sulfur dioxides. These are all highly pollutants. They causes the environmental pollutions, health hazards. It's a one major drawback of this uh, conventional energy sources. And also they are exhaustible. Okay, in the future, if you continuously used, in the future they may exhaust. And they are, apart from the energy sources, these may be raw material for the some of the chemical industries, the some of the paint industries. Okay, they may also use for these industries, but in the future they are not available because of the continuous usage. The safety, and another drawback is safety. The safety of nuclear power plant is highly hazardous, because the whatever the rays are generated by the nuclear power plant, it is highly hazardous for the human beings as well as the animals. Okay, it's another drawback. Hydroelectric power plants are cleanest, but large hydro reservoirs having a major problems. And the large land, they requires a large land, large areas, large submerged water. Okay, deforestation, geological disturbance, earthquakes, these are all things just because of the conventional energy sources. Okay, so again, they're having an advantages, they're having an disadvantages. Apart from with these things, we switch on to the commercial, non-commercial, and non-conventional energy sources. And this whatever the module is highly uh, concentrated or highly pointed on the non-conventional energy sources. Yes, non-conventional energy sources. In that, the first energy comes is solar energy. Yes, you can see in the picture. So, what is meant by solar energy? One thing you should know: sun is the basic source for all the energies. Sun is the basic source for all the energy. Means the sun will provides energy to all the sources, maybe human being, maybe animals, maybe plant. By the sun only we got the energies. Okay, and different form of energies, again we converted into different types of energies, and finally it is used for usable form like electric energy or chemical energy. The solar energy is very large. It is inexhaustible source of energy. The power from the sun, the power from the sun is directly by the earth, approximately 1.8 into 10 raised to 11 megawatt. It is 1.8 into 10 raised to 11 megawatt, which is many thousands times larger than the present consumption rate of the earth of all commercial energy sources. Means whatever the sun energy we got from the sun is 1.8 10 raised to 11 megawatt, and this energy, it is equal to many thousands time. Means in our earth we are using 100 megawatt. Let us assume that 100 megawatt, it's a consumption per hour, and whatever the energy is 1.8 into 10 raised to 11 megawatt, means it is thousands times of energy whatever we are using from all source, all commercial energy source, which is equal. Means that enormous amount of energy is coming from sun to earth, but we are only using a small amount of solar energy. Thus, it's the principle of solar energy would supply all the present and future energy needs of world on a continuing basis. And this makes it one of the most promising unconventional energy source. It's a one of the most promising unconventional or non-conventional energy source, because it is providing an enormous amount of energy for our earth crust. The solar energy is received in the form of radiation. We not directly get the any form of energy, only we get solar rays. Solar rays or radiations can be converted directly or indirectly into the other form of energies, such as heat, electricity, and this energy is radiated by the sun as an electromagnetic waves, of which 99% have wavelength and ranges zero point 0.2 to 4 micrometers. This we will discuss in the next topic, that is solar radiations and solar constant. In that we will deeply we will discuss. Okay, and here we got in the first picture you can see this is the sun. Okay, and from the sun it will emits the rays. Okay, in all the direction it will emit the rays, and only the earth surface will receive some amount of rays. Okay, that rays is called as radiation, solar radiation or solar rays. Okay, and these rays having an large amount of heat energy, and this solar rays are fall on the earth surface or fall on the some devices. That device is called as solar panels. See, this is a house. On that house there is a solar uh, rays are falling on the panels. Okay, so these solar rays are converted this heat energy into electric energy. So these are the devices. See, in the first picture you can see house. On the house there is a solar panels and the solar rays falling on that solar panel, and some continuous devices are attached, and these devices are convert this heat energy into the electric energy, and after that electric energy we can use to drive the so many devices or appliances on the house, to for lighting purpose, for refrigeration, for fan. Okay, for AC we can use this energy, electric energy. And here how the conversion solar energy. Okay, here the rays, solar panel, the solar panel gets converted into electric energy. Okay, DC energy, we cannot use directly DC energy. Again there is a device or so that circuit, that circuit will convert this DC and into the AC, and it then after this energy is stored in the electric batteries. Okay, and in battery that electric energy is converted into chemical energy, and once we required energy again that chemical energy is converted into electric energy with the help of this device, and we can use for our appliances. Okay, this is how the circuit, solar energy from the sun to ultimately to operate the fridge we need whatever electric energy. Okay, and in the bottom there are three important pictures. One is a middle picture, it is what it's a solar panels, huge amount of solar panels are installed, and this is a place where in the Rajasthan, of course it is India. Okay, Rajasthan having an number one solar stations. Okay, here thousands of solar panels are installed, and they generated a large amount of electricity. And next the two more pictures which It's another applications of solar panels is solar trees. It is also called as a solar trees, just like a tree, just like a branches, and every branches they placed a solar panels. Okay, so these solar panels again converts that solar energy into the useful energies, electric energy. And of course in India also we can see some of the solar trees installed. Okay, they are very useful. With a small area we can install large solar panels. So next is classifications of method for solar energy utilization. So solar energy utilization, uh, the first is direct method and indirect method. So direct method means directly we can convert that solar energy, means thermal energy and photovoltaic. That is what we discussed, solar panels and solar water heater. So in our house, I think most of having an solar water heaters. So solar water heater, what happens, the solar energy is converted into heat energy or thermal energy. So because of the thermal energy water get heated. Okay, so it's a direct method of conversion, thermal energy and photovoltaic energy. And indirect method of conversion is solar power. So water power means again, I told hydroelectric power. It is also indirect form of solar energy. Means because of the sun, the water get evaporated, and once the water get evaporated and it forms the clouds, and in the rainy season again there is a rain from the cloud, and again that water due to the rain it is collected in the dam, okay, or reservoirs, and afterwards that dam or reservoirs again that water is fall from the higher level to the lower level and get converted electric energy. Again because of that we need a heat energy. That heat energy is supplied by the sun, so that the water get evaporated. It is a water power. And wind energy, because of the heat energy, the wind get energy and get velocity, and it will start flowing with a high velocity. Once it is flowing with a high velocity, again it will rotates the windmills or wind blades and generates whatever required electric energy. And biomass, of course, the plants and agricultural waste from the sun, they got the energies, photosynthesis. Okay, from the photosynthesis they convert some energies, and that energy after the bio waste or vegetables or fruits, and those things were decaying in the plant. Okay, in some area, and because of the fermentations they produces the gases. Okay, or they produces the fuels, the biofuels or biogas. Okay, for that also again sun is the main source. So these are all indirect. Ocean energy means of course in the top layer and bottom layer and intermediate layer, the ocean is having an very high depth, and in the top layer of the ocean having an higher temperature, and the bottom layer is having a low temperature, and middle having an intermediate temperature. By difference in this temperature, it is because of the sun, and again by difference in this temperature we can generate the electric energy. It is also indirect form of solar energy. And marine current, wave energy, ocean temperature difference, these are all indirect. Means directly only thing is thermal and photovoltaic, we directly we got the energy. But indirect means first it will into the some other form and then we got the energy. That is indirect method. Okay, so this is what the classification of solar energy. So next thing is merits of solar energy and demerits of solar energy and solar applications. Okay, so merit. So what are the advantages of this solar energy? We already know that solar energy, uh, it's having a lot of advantages. It's having a lot of advantages when compared to the non-conventional energy, conventional energy source of energies. Okay, the first important merit is it is environmental friendly and clean source of energy. It is environmental friendly, eco friendly, and it produces very less amount of pollution, and also it won't produce like toxic materials, toxic gases like nitrogen oxide, sulfide oxide, okay, or carbon dioxide or carbon monoxide. It is very eco friendly. It won't produce such toxic byproducts. Okay, and it is a very clean source of energy, and it is freely available, adequate quantities, and most of all parts of the world we can get this type of energy. Apart from the south and north pole, we get almost all the surface on the earth crust, we get this energy directly onto the surface. And demerits of this, of course there is a lot of advantages are there, but these are the major advantages. And come to the major drawbacks of this solar energy. It is a dilute form, okay, and it requires a large collecting areas, and also the energy availability is not continuous. Sun is maximum in the noon time, and it is very less in the night time, so it is not continuous one, and it requires a large space for collection, okay. And also it is a dilute source of energy, and means the efficiency is less compared to the commercial source of energies. And come to the applications, in the picture you can see it's a one common application, solar water heater. And this is solar panels to glow the lights on the highways. You just observe highway lights are just supply electricity by the help of electric solar panels. And this is a one electric car, solar electric car, due to the solar panels on the roof of the car, and that solar energy converted into electric energy, and it drives the car. And of course solar coolings are another example. Solar pumping is also there, solar furnace, solar water heater, solar cookers. Solar cooker is also best example. Next, food generation, so refrigeration, solar refrigeration, solar furnace, solar pond, solar steam generator, solar reflectors, solar electric power generation, and solar distillation, water distillation, solar greenhouse. So many examples, so many applications we can see with this solar energy. So by all these, we can conclude that solar energy is an one abundantly available on the earth crust, and it is very very essential for future days, just to replace the conventional source of energies. Hello.